So we want to determine the coefficient of friction, and you're going to do it the way that a grown-up would do it. Okay? So there is some adult content here. Why does that always mean like a bad thing, right? Adult content. Adult books. Like Shakespeare. I don't think that's what we have, right? So basically, the coefficient of friction, right? The force of friction is mu times m times g, okay? And all we're going to do is we're going to measure the force of friction, and we're going to put different masses on there. And if we measure the force of friction, we put different masses on there, we shouldn't, when we make a graph of this, right, our graph should be, if we go force of friction and m times g, right, the weight, what should the graph look like? Yeah. Yeah, it should go upwards, and should it go up like this? Should it go up like this? Or should it be a nice straight line with a slope of mu? It's going to be a nice straight line with a slope of mu, isn't it? Yeah? Okay, so what a grown-up's going to do, by the way, is if you're an engineer and you're trying to determine what this coefficient of friction is, you're going to find all these points, and they might not be exactly collinear, right? And then you're going to actually put a straight edge through this. I have a straight edge. Okay? You're going to put a straight edge through that, and you're going to find the slope of the line. That's what an engineer would do, and that's what I'm going to show you how to do. All right? And luckily, in the past, it was you just sort of eyeballed it. And notice that not all the points even touch the line. In fact, they could possibly, it's not likely that one actually would touch the line, right? Okay? Points and lines being what they are. But what was I going to say? I don't know. I don't even know. But this is how you would do this, right? Is you would actually find the slope of this line, right? And here's the beautiful news: is that we would do this by hand back in the old days, right? By just kind of eyeballing like this. Right now, we can right-click on that, and Excel will tell us what the model is for that line. They'll tell you what mx plus b, right? Isn't that a very beautiful thing? I think that's a beautiful thing. Yeah. Okay. So this is what you're going to do, and you can read the directions in there, right? Perform step 2 after adding these masses to the block. So we're going to take the block and see how hard it is to drag it with nothing on it, right? Okay. Okay. We're going to add 250 grams. We're going to add 500 grams, 750 grams, and 1,000 grams, a whole kilo, okay, on there. And if you take the block, you can, for this, and where is my block? Oh, Duggan's got them right here. Okay. If you take this thing, you can find the mass of this block by just putting it on a scale. And Duggan says don't write the mass on there. That's just fine. But we have these triple beam balances there. I think you guys know how to use them, yes? Make them read 0 beforehand and then slide it over and then add up all the numbers, and that'll be the mass of it. This one's going to be about 245 grams. So you can just go right to there and then just see how far off of that it is, right? Okay. So I'm going to say that this guy's 245 grams. You have to mass your own block. Okay. So this one's going to be, well, it's going to be 250 plus 245, and this one's going to be 500 plus 245, et cetera, right? Okay. So we're going to have to add those up. And then we want to find, for our data, we want to find the static force, right? And then we want to find the kinetic force. Force, there we go, right? And then ultimately, we're going to want to calculate the static coefficient, right? And then also, we're going to want to calculate the, holy cow, we're just running out of whiteboard here, the kinetic coefficient. And I'll show you how to do this. I'll show you how to do this using Excel, so you won't go crazy, okay? At least hopefully you won't go crazy, right? Okay. So let me just show you how to gather a data point, and then I will, let's zoom in on the table here, okay? And then I'll show you how to set up the spreadsheet, and then by then everybody will be asleep except for one person, and so that one person can then wake up the rest of the people, and we'll go do our skill set. Yeah? Yeah? Does that sound like a plan? Yeah. There we go. Okay. So I recommend, in fact, I would just say don't do anything else but this. Use the 5 Newton scales. We've got 20 Newton scales. We've got 2.5 Newton scales. But in my opinion, the 5 is the one to go with because the 2.5 is not enough and 20 is too inaccurate, right? Concept 0, these things have a little scale that slides like this. Do you see that? Right? So what you want to do is first make it read 0 when you hold this thing sideways. Yeah? There you go. Right? So now it's reading 0. And then what you do is you put something on here, and I'm going to put the 500 grams on there. But you're going to do this with nothing on there, 250, 500, 750, 1,000, right? I'm just going to put the 500 on there. I think that's 500. There we go. Right? And I'm going to pull on there. And what we're looking for is the highest number I can get before it starts to move and the number that it is when it is moving. Yeah? The highest number we can get before it moves and the number that it gets while it is moving, right? So set this thing on here. It helps to sort of steady your hand on the table. And I got 2.2. Every little tick mark is 0.2 of a Newton, right? 2.2, 2.4, 2. There we go. Looks like I almost got it to 3, didn't it? Yeah? Doesn't it? Let's look at that again. I'm looking at that first number there. I'm going to say, what, about 2.8 maybe? Right? So my static friction at 500 newtons, static force is about 2.8 newtons, right? And now the question is, what is the force that it slides with, right? Yeah, I'm going to do all that in the spreadsheet. I'm too lazy to do it by hand, you know. That's how lazy I am, right? So let's see what it drags at. Well, I'm dragging it at under 2 newtons, about 1.6, isn't it? Does that look like that? Oops. I know it's hard to say what it is, right? I'm going to say 1.8, right? Okay. So there's quite a bit of difference between the static and the kinetic force, right? Okay. And then you're going to try this. So when you do this, the clue I'll give you is when you pull on it and try to find that static force, you notice how I'm stabilizing my hands on the table like this? You see that? That really, really helps. Don't shake the table because you'll break those little chemical bonds that are allegedly responsible for the static friction, right? So just kind of pull it, pull it, pull it, pull it. Oh my God. It's highly variable, right? We got it up like 3.4. So you could do a bunch of trials if you feel like a great scientist or something like that, right? Okay. And anyway, there we have it, right? And then I'm just going to make up numbers here. How about, let's make this guy be about 1.9, and this guy be about 1.1, and this one be about 3.5, and this one be about 4.2 or something like that, right? And then let's make this one be 1.2 and 0.6 and 2.4. I'm making up like a perfect straight line there, aren't I? Yeah? Okay. You're going to actually measure those, but I'm being a bad scientist and I'm fabricating data here, right? You would never do that. And then let me show you what to do with Excel. And some people excel at this. But some people, it's not their forte, as it were. Okay, so first thing to do is to run Excel. Okay, and I believe, does it tell you what to do? Make 2 graphs for all the trials, blah, 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 blah. It doesn't tell you a specific thing, so I'm just going to show you a suggestion. It might be helpful for you to write down sort of vaguely what I'm doing here, right? So I think I'm going to say added mass, right? Total mass, right? I'm actually going to put a column in here for weight. Okay, then I'm going to go static friction. I'm going to say static force, kinetic force. So static is that first one that it is before it slides. Kinetic is the one that it slides at. And I'm going to resize those guys. Okay, and then I'm going to go static. St mu is the coefficient, right? And I'm going to